In this proof, we're going to use a combination of relationships that involve parallel lines. So notice, in the given, I know that C and D are parallel. So I can mark that in my picture. I suppose we can go ahead and include that. C is parallel to D. That's one of our givens. So I also have a given about an angle relationship. I know that angle 1 is congruent to angle 3. So I can mark that also. And then between these two givens, we have to decide which one we want to start working with. And angle 1 being congruent to angle 3 isn't going to help us right now, because this isn't a pair of angles that's formed when a single transversal crosses two lines. So there isn't a common transversal between angles 1 and 3. Notice angle 1 is formed by lines C and A. Angle 3 is formed by lines D and B. So there really isn't anything that I can do with angles 1 and 3 right now. So I need to start with C being parallel to D, and I want to find a special angle pair that is created when those parallel lines are crossed, and I can work with a relationship between those. So here are C and D. Notice, if you use A as the transversal, only one angle is marked along that transversal. So I'm trying to suggest to you that maybe that's not where you want to work. Maybe you want to work along the other transversal, transversal B. So here, if I know that C and D are parallel, I can conclude then that angle 3 is congruent to angle 2. Those are corresponding angles that are congruent. So starting with the parallel lines, I can say that angle 3 is congruent to angle 2. And what's important here is the parallel lines came first, the congruent corresponding angles came second. So literally, that's exactly the order in which I want to write my reason. Parallel lines, again, that came first in the given. That leads me to this statement that these corresponding angles are congruent. That's the corresponding angles postulate. So then notice, now I have 1 is congruent to 3, and I know that 3 is congruent to 2. So again, these two angle pairs I can connect using the transitive property. 1 connects to 3, but if we leave off here with 3, we can pick up with 3 here and connect it to 2. So we can directly connect angle 1 to angle 2. Those two are congruent angles. That's the transitive property. And now we have a relationship that will be helpful, because if angle 1 and 2 are congruent, let's mark that in the picture. Angle 1 and angle 2 are formed by the transversal C. So notice, if angle 1 and 2 are congruent, those are alternate exterior angles that are congruent. What that allows me to do then is to claim that A and B are parallel lines, and notice that was the proof statement. So we're already in a position where we can make our conclusion that A is parallel to B. Again, 1 and 2, those are alternate exterior angles that are congruent. That comes in step 3, that comes first, and that leads us to the conclusion in statement 4 that the lines are parallel. So literally, that order, congruent alternate exterior angles, gives us parallel lines. That order is exactly how we write our reason. So angle 1 is congruent to angle 2. That's really alternate exterior angles, which are congruent. And that leads us to the statement that finishes the proof, statement number 4, A and B are parallel. So what's important when you do proofs like this is to stay organized and decide when are you using parallel lines first and when are you using parallel lines second. So to begin the proof, we started with the parallel lines in order to make the conclusion about 3 and 2. That's why my order here is parallel lines first, corresponding angles that are congruent second. But at the end of the proof, notice I want to make a conclusion about the parallel lines. So I'm starting with my congruent alternate exterior angles first, and that lets me make my conclusion about parallel lines second. That order is the key.